Okay, so remember, we were working on the definitions of our trig functions. So just our quick refresher. We used SOHCAHTOA to help us, but we can't only use that, and we'll see some scenarios today. So the SO was telling us sine was the opposite side divided by the hypotenuse. But we also had an x, y, and r definition. So if you take a point, and if you're looking at the point on that line, you can think of a triangle connected to the x-axis. This is your x value, your y value, and r. So if we look at that, the opposite over hypotenuse sine is y over r. And do you guys remember which one was the reciprocal of sine? Cosecant of theta. So that would be hypotenuse over opposite, or r over y. Okay, the ca says cosine is the adjacent divided by the hypotenuse. So the adjacent side is x, hypotenuse was r. Reciprocal of cosine is secant, would be r over x. TOA is tangent. Tangent of theta is opposite over adjacent, or y over x. And the reciprocal of tangent is okay, so that's what we were working on Friday. And I would give you an ordered pair and tell you it was on the terminal side, and we would use that to find x, y, and r and give our ratios. The ratios are always written as a fraction in lowest terms. You might have radicals in them. Break down your radicals as needed and reduce. Now let me ask you a question. If I took a point here, okay, we have this triangle. What if I had picked a different point on this terminal side? Like, what if I had picked the point out here and used this triangle? Do you think the trig ratios would be different? The x, y, and r would be, wouldn't they? But what these two triangles would be similar triangles. And so that means the final proportions would turn out to be the same once we put them in lowest terms. So technically, we could pick any point on this terminal side that we wanted. Everybody in the class could use a different ordered pair, and our final answers would reduce to the same thing. So let's try this one. Find the values of the 6 trig functions of angle theta and standard position if the terminal side of theta is defined by 3x minus 2y equals 0. X is less than or equal to 0. So instead of giving you an ordered pair, this time I gave you the line. Okay, I need actual values for x, y, and r though. So what I'm going to do is use this line to get my values. I can pick any x that I would like, as long as it meets this requirement. I don't want to do x equals 0 because that's the origin or the vertex. So I need a different point less than 0. -1. Okay, then I picked a number. I can plug that in and get my y. I add my 2y over. And my y is -3/2. Okay, will this work? We have x, y. Can we get r? Yep. Is anyone uncomfortable using a fraction for one of these points? I mean, as long as you're okay with it, we can. We'll have to reduce a fraction and a fraction, but it's nothing we haven't done before. If you really don't like the fraction, then you can pick a new x and y. Easy trick. What's on the denominator of this one? 2. I could multiply both of these by 2 and get a new x and y. So I could do a -2 and a -3 if I multiply them both by 2. And then I don't have fractions to deal with. They're still both on here. This would be -6 plus 6. It still equals 0. Then I just don't have the fractions. So do you want to use -1 and -3 halves, or -2 and -3? Okay. Then we need to get r. So remember, x squared plus y squared equals r squared. We got that from when we drew a triangle. You know, if I'm doing -2, -3, it's just Pythagorean theorem to get that r. So 4 plus 9 is 16 equals r squared. R is always positive, so my r would be 4. What did I do? That's not right. 13. So my r is just the square root of 13. Okay, it's okay that it's still a radical. Don't turn it into a decimal. Leave it in radical form. No perfect square divides 13, so that's all I can do. So now we can do our 6 trig functions. Okay, if you've drawn a picture, you can use SOHCAHTOA to help you, or we can practice our definitions. The definition of sine, we said, was y over r. So my y is -3. My r is radical 13. We can't leave a square root on the bottom. How do we fix that? On top and bottom. So we get -3 radical 13 over 13. Cosine is x over r, or adjacent over hypotenuse. So -2 over radical 13. Again, move the radical, multiply by radical 13 on top and bottom, so -2 radical 13 over 13. Tangent is y over x, or opposite over adjacent. So -3 over -2, which just reduces to a positive 3 over 2. If we have these, we can get the reciprocals. You just have to know which ones go together. So the reciprocal of sine, cosecant. My suggestion, what's going to happen if I try to flip this final answer? It's going to put the radical 13 back on the bottom and I have to move it again, which I certainly can. But in this case, I think it would be easier to do the step right before I move the radical 13, and then I don't have any extra reducing. Or you can just use your definition, r over y. Reciprocal of cosine is secant, so again, you can do r over x, you can do the final answer. If I'm going to flip it, I flip the step before I move my radical, so negative radical 13 over 2. Reciprocal of tangent is cotangent, so that would be 2 over 3. Do we have questions? So everyone understands how I got my numbers? Do you guys want to try one of those? So what you have to watch, we have an equation, and you have to pick an appropriate x value. What kind of number does x have to be? Greater than 0. So any positive number will work. So you picked a positive number for x. If I'm looking at this, I know if I'm going to solve for y, I have to divide by 2. So I'm going to pick an even number if I want to avoid fractions. But any positive number will work. If I put that in, then I get my y to be -1. Then if you do x squared plus y squared equals r squared, r is the square root of 5. So sine y over r, negative 1 over the square root of 5, multiply by square root of 5 on top and bottom, so you get negative radical 5 over 5. No matter what you picked for your x, y, and r, even if you had different numbers, it should reduce to the same thing. Cosine x over r, so 2 over the square root of 5, multiply the radical 5, so we get 2 radical 5 over 5. Tangent y over x, so negative 1/2. Reciprocals, cosecant is r over y, or the reciprocal of sine. So you just get negative radical 5. Secant, r over x, so radical 5 over 2. And cotangent, x over y, so 2 over negative 1, or negative 2. How did we do on those? Do we need another question like this? Let's look at this question. Find the values of the 6 trig functions for a 360-degree angle. (360 degrees), that means we know it starts here. 360 is all the way around. So my initial side and my terminal side are the same. So I just need a point on this side. What's the easiest x value I could use? 1. What's my y value? Since we didn't go up or down at all. So we have a point. Okay, you can pick any positive number for x and your y is 0 if you're on the x-axis. If I find my r, r is also 1. Is it possible to draw a triangle in this problem? No. So this is where that SOHCAHTOA definition doesn't help. That's why we have to have x, y, and r for some of these. So sine is y over r. My y is 0, r is 1, so sine is 0. Cosine, x over r. So in my ordered pair, the x value is 1, my r is 1, 1 over 1 is 1. Tangent, y over x. So my y is 0, x is 1, 0 divided by 1, 0. Cosecant, reciprocal sine, or you can think r divided by y. Can you do 1 divided by 0? No. We typically just, you'll see the word undefined. If you put no solution, I'm not going to count that wrong, but you'll see undefined written a lot in trig. Okay, reciprocal of cosine is secant. R over x, so 1 over 1 is still 1. Reciprocal of tangent is cotangent. X over y, 1 over 0 is undefined. So these are the quadrantal angles. If it ends on an x or y axis, you're going to see different answers for those a lot. You'll see a lot of zeros and undefineds popping up on those problems. I think the last thing I want to do I want to practice just some of those quadrantal values. And I'm just going to use this picture to help us a little bit. So we know if we were here, we said the point was 1, 0. What would it be if you ended on this axis? What's your ordered pair?
0, 1.
Okay, if you ended on this axis. What about down here?
0.
In all of these, if you did x squared plus y squared equals r squared, what does r turn out to be? 1. 1 squared plus 0 squared equals r squared. And 0 squared plus 1 squared, they all turn out the same. So if we use those points on all of these, r is 1. Okay. I'm just going to ask some questions. If I ask you to tell me the sine of 90 degrees, what's the definition of sine?
Y over
Okay, where is 90 degrees?
top of the y-axis.
So if I'm there, my y value is 1. R is always 1. So we get 1. 1 divided by 1 is 1. What if I asked you for the tangent of 270 degrees? What's the definition of tangent?
Y over x.
Okay, where's 270?
Bottom.
Right, remember these are just multiples of 90. 0, 90, 180, 270. Okay, what's my y value? X. Negative 1 divided by 0. What if I said the secant of 180 degrees? Secant's the reciprocal of cosine. Cosine is x over r, so this would be r over x. At 180, r is always 1. X is, so 1 over negative 1, negative 1. Are we okay with that? So I could ask you to evaluate some of these. My suggestion, there's a section on the homework that asks a lot of them. Draw the picture one time. You don't have to redraw it on every single question. Draw it one time and use your definitions to help you. Tomorrow, we are actually close to being done with chapter 1. There's only one more section. So it's a short chapter. Tomorrow, we're going to do a quiz over what we have done so far. I will review the first part of class. So that would be like the beginning, complements, supplements, knowing the degrees, minutes, seconds, using that. Then we got into similar triangles and those angle relationships. And then this section, the X, Y, and R definitions. So tomorrow we'll grade homework, go over any questions. I'll do some review problems, and then we'll have, won't be a very long quiz, but a quiz over that just to make sure. I like to have a quiz at least once in a chapter before we get to the end of the chapter and we're talking about a test. So we will have that tomorrow. Your assignment, you guys have a lot of time to work on this right now. So this is what we did Friday, so we're going to add those to it.